Hello, third graders. Today we are going to be talking about...
Hold it! Hold it! What are you wearing?
Well, I just wanted to dress up for the kids.
Miss Brown? Russ is wearing all his fancy clothes, and I thought we were here today just to teach math.
Jack, Russ has decided to wear his fancy clothes to teach the kids. If you want to wear something, you can wear something. But look, they're ready to start. Can we start, please?
Sorry, Miss Brown. Yeah, we can start. Okay, Russ, what are we talking about?
Today we're going to be talking about...
Times? We talked about times 2 weeks ago. Time!
I heard you. We already talked about telling time.
Times!
No, everyone listen. Not telling time. We're going to be talking about multiplication and division. Not times, multiplication and division. Okay, got it? Hello, everyone. I'm a multiplication sign. When we're doing a multiplication problem, we're showing equal groups and the same number in each group. Hey, Miss Brown, can you show us a problem? Before she does, there's 2 words I think we should review. First is factors. Those are the 2 numbers that we're multiplying, and the product is the answer. So if we have the question 4 times 3 equals 12, 4 and 3 are factors, and 12 is the product. Let's start with the problem 5 times 3. Now I have 2 factors, 5 and 3, and I can solve this by drawing 5 groups of 3 objects or 3 groups of 5 objects. I like to compare those 2 numbers and know that 3 is smaller, and I like to use that for my number of groups. So since whatever the smallest factor is, I'll draw that many circles. 3 groups. Next, I see that 5 is my next factor, so that means I need to put 5 in each group. I like to use tallies just because I find them neater, and I have less of a chance of forgetting one when I'm counting it up. So I have 3 groups of 5 objects, and then I count them up. 5, 10, 15. So that means 5 times 3 equals 15, or 15 is the product. Let's try the problem now, 7 times 4. I look at my 2 factors and I see that 4 is smaller than 7, so I'm going to draw 4 groups this time. And again, I'm going to make sure that my circles are about the same size, but they don't have to be perfect, but not crazy and messy and all that good stuff. Now that I have my circles, I'm trying to center it so you can see it. There we go. Now that I have my circles, I'm going to put 7 tallies in each one. So I'm going to put 5 on the top and 2 on the bottom. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. This means I have 4 groups and 7 in each. Then I'm going to first count by 5s. 5, 10, 15, 20. And then I'm going to count on from 20. 20, 21, 22, 23, 24, 25, 26, 27, 28. 7 times 4 equals 28. Okay, but you said that we were going to talk about multiplication and division. Where's that division guy? Ooh, sorry I'm late. I was just trying to get some brownies out of the oven.
Hey, it looks like your butt's on fire.
I don't have ears. I can't hear you.
It looks like your butt is on fire.
What? I can't. My butt is on fire. I gotta go. Oh no. Well, I guess it's time to bring in the backup. Hello everyone. I'm a division symbol. In a division problem, you're going to take a total number of items and divide it up equally into groups. Miss Brown, would you please show us a problem? The first one let's try is 12 divided by 4. You'll remember in division that the first number tells me how many items I'm going to divide up. And my second number, I like to say, tells me how many groups to draw. So that means when we look at a division problem, I know this number is how many items I'm going to divide up, and the 4 tells me that I need to draw 4 groups. Now this is a little bit different than multiplication because I'm not going to draw 12 items in each group. That's multiplying. Instead, I'm going to divide 12 items up into these groups. I like to use tallies again. So I'll start, I need to make sure I have 12 here, and I need to put an equal number in each group. So I'm going to go 1, 2, 3, 4. Still not to 12, so I'm going to keep going. 5, 6, 7, 8. Still not there, keep going. 9, 10, 11, 12. I had 12. I split it up into 4 groups, and I have 3 in each group. So 12 divided by 4 equals 3. Okay, how about a larger number?
Like 1 billion.
How about 32?
Okay, I guess that's good too.
Okay, so 32 then. Let's try the problem 32 divided by 4. This means I have 32 objects, and I'm going to be dividing them into groups of 4 or putting 4 in each group. When I'm drawing a picture and using that as a strategy, I like to say that I'm dividing it into 4 groups. I'm going to draw them a little bit bigger because I know 32 is a little bit larger of a number. Now I could sit here and count out 1, 2, 3, 4, 5, 6, 7, 8 and go all the way up to 32. But one strategy that I like to use to make it go a little bit faster is see if I can put just groups of 5 in each circle. So I'll count up 5, 10, 15, 20. Since I'm not at 32 yet and I'm only at 20, I've already divided up 20 items and I only have to count from 20 to 32. So 5, 10, 15, 20. I'm not at 32 yet, so try to put another 5 in each group, 25, 30, 35, 40. That's way past 32, so that won't help me. So I've counted 5, 10, 15, 20. I'll go back to ones. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I had 32 items. I divided it into 4 groups, and there are 8 in each group. I'm going to do this one more time because I know division can be a little bit tricky. So I'm going to do 16 divided by 2. I'm going to have 16 tallies, and I'm going to divide it into 2 groups. So I'm going to make 2 large circles because that's what this 2 means. It means I have 2 groups, and I'm going to divide 16 among it. Now again, I can count 1, 2, 3, 4, 5, 6 and divide it up evenly until I get to 16. Or I can try, can I put a 5 in each one? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not up to 16, so I'm allowed to do that. I'm going to try to put another 5 in. So 5, 10, 15, 20. If I put another 5 in, I'm past my 16, so that doesn't work. So I go back to 5, 10, and I'm going to count on from there. 5, 10, 11, 12, 13, 14, 15, 16. I had 16 items. I divided it into 2 groups, and there are 8 in each group.
All right, fantastic. So, everyone, if these students should remember one thing, always wear pants when you get your mail. I meant cover your mouth when you sneeze. No, listen, guys, if you pass gas, make sure you say, "Excuse me." Hold up. I mean, great advice, everyone, but a tip about multiplication and division. I know. Pick me. They're going to pay really, really, really close attention to if there was a multiplication or division sign, because they pay really close attention. Right, guys? You were looking for me this time, right, guys? You learned from last time? Guys? Right, guys?
Now, parents out there, you might be asking, why is my child having to draw pictures of multiplication problems? Shouldn't they just have this memorized? And our answers as teachers is yes, we would love if your students had these math facts memorized, and we're going to give you some activities to practice those math facts in memorizing them. But these are just strategies that in the meantime, while you're learning the facts, helps you still get the problems correct. The other answer is, well, sometimes your students are given a picture like this one, and they're asked what multiplication problem is shown by the picture. And so they're going to have to be able to tell that we have 3 groups, and there's 5 in each group. So this problem is showing 3 times 5 equals 15. And hopefully all of your students are saying or, because we can always flip that equation. So it's 5 times 3 equals 15. And hopefully your students are saying or, because we can finish the fact family as well. So the answer is, should my students have these facts memorized? We would love if by the end of 3rd grade we would have 1s, 2s, 5s, and 10s memorized. And I always like to throw in 3s because we have a fun song for memorizing 3s. But if memorizing facts is something that's difficult, we always have these pictures to help us. And we're also going to have to be able to identify from a picture what multiplication fact is being shown.